Alright, so let's recall the example from the previous section with the arm spans and heights. So recall we have 24 people. So the sample size is 24. And we calculated beta 0 hat and beta 1 hat in the previous section. And we're going to have to calculate more things. So let's recall all these quantities. So S is equal to 1 minus r squared times the sum of yi minus y bar, whole thing squared, over n minus 2. So S is the standard deviation of the errors, epsilon I. And after we know the value of S, then we can calculate the standard deviation of beta 1, which is S over the square root of the sum of xi minus x bar squared, and S beta 0 hat is S times the quantity, square root of quantity 1 over n plus x bar squared over sum of xi minus x bar, whole thing squared. Okay, so all these quantities can be found somewhere in the chart or calculated directly using the Excel. This is x bar, this is y bar, and the sum of xi minus x bar squared is equal to the sum of xi squared minus n times x bar squared. That makes calculation easier. Same with the sum of yi minus y bar, whole thing squared. This is equal to the sum of yi squared minus n times y bar squared. Okay, and n is 24. I think that's all we need. And r is the sample correlation coefficient. So r is equal to the sum of xi yi minus n times x bar y bar over the sum of x bar squared, xi squared minus n times x bar squared. So all of these can be calculated using a spreadsheet. You should use this to calculate using a spreadsheet. So this is our value of S, and this is S beta 1 hat, and this is S beta 0 hat. And in the previous video, we said the degree of freedom is equal to n minus 2, which in this case is 22. Okay. So knowing all these, then we can calculate the confidence intervals for beta 1 and beta 0. So let's first calculate the 95% confidence interval for beta 1 and for beta 0. Okay. So the confidence interval for beta 1, the center is going to be our observed value of beta 1, which is beta 1 hat. So this is 1.157 and plus minus. So degree of freedom is 22 and alpha is 0.025 because it's two-sided. So if you look at the table, this is 2.074 and times the standard deviation, which is here, which is 0.098, sure, 3. And this is equal to 0.95, comma, 1.36. And we can do the same thing for the confidence interval for beta 0. So for beta 0, the center of the confidence interval is our observed value, which is the beta 0 hat. So it's minus 22.55 plus minus degree of freedom is still n minus 2, so it's 22. And alpha is still 0.025, so the t value is the same. It's 2.074 times the standard deviation, which is this. So it's 16.536. So this is equal to negative 556.85, comma, 11.75. All right, so now we know how to calculate confidence intervals for beta 0 and beta 1. We can also do hypothesis testing for beta 0 and beta 1. So let's do a couple examples. So let's test H0 is beta 1 is less than equal to 1, and H1 is beta 1 is greater than 1. Then the null distribution is t-distribution with center 1, and our observed value here is 1.1567. So to calculate the p-value, first we calculate the t-statistic. So t is equal to 1.1567 minus 1 over the standard deviation, 0.0983. So this is about 1.597. So this tells you that p-value is equal to t is equal to 1.597, and then the degree of freedom is still 22. So you look at the table for degree of freedom equal to 22, and we know the p-value is between 0.1 and 0.05. So 0.1 gives you the value in the table, which is 1.321, and 0.05 gives you 1.717, and 1.57 is between the two green numbers. So p-value is between 0.05 and 0.1, so we cannot reject H naught at 5% level. And we can do a similar example for beta 0. So if you want to do a hypothesis testing for the null hypothesis is beta 0 is positive, greater than or equal to 0, and H1 is beta 0 is negative. Then the null distribution is this t-distribution with center 0, and our observed value is negative 22.55. So the t-statistic is equal to negative 22.55 minus 0 over 16.536. 36. This is a 5. And this is about negative 1.364. So the degree of freedom is still 22. So if we look at the table, then 1.364 is still between 1.321 and 1.717. This number is between the two numbers. So the p-value is still between 0.1 and 0.05. So same thing, we still cannot reject H naught at the 5% level. All right. So aside from the complicated formula, everything else is consistent with the previous chapters.